Yeah, I believe you can see the screen, and if you can, just an emoji reaction. Yes, a large casola, and yeah. Okay. Emmanuel still reviewing last week. Uh, so you're mentioning that you're still reviewing last week. Okay. Yeah, you need to do that complete review. Yeah, we talked about something on vectors and matrices. And for you, how to create a vector. I mean, we talked about that, and I think that is something that it's a long one. So you'll just have to go through that, but we can just look at the basic of how can you create a vector, or how can you create a matrix. Let me just go and do it down here. Yeah, so suppose maybe you want to create a vector called a vector. We said it's something that contains elements of the same type, right? We say that it should be containing elements of the same type. So tell me if it's V1, and I know that it contains maybe numbers like 23, 34, 67, 45. Maybe these are the ages of those who are present in the class. So there is somebody with sweet 16. So this is a vector, right? And you run it by pressing Control Enter. You have maybe vector 2, and somebody is 20, 18, 17, 15, and maybe something like 19, right? This is also another vector. You've created a vector, right? You can even add those vector by saying v1 plus v2, and then you can see 43. So 23 plus 20, 34 plus 18, 67 plus that, and blah blah. Suppose maybe you had this is because they are of the same length. How about if you have maybe 21 here and run all this? It will tell you that one of the objects is longer than the other, right? Long object is not a multiple of short. So you only add if they are of the same length. You can even do vector multiplication. Those who want to do multiplication, you can do subtraction there, you can do multiplication, and you can even do division, right? These are things that you can run them and see. Sorry, what's okay? Let's okay. Now you can see maybe vector 1 plus vector 2, 43, 52. Vector 1 minus vector 2, 23 minus 20, 34 minus 18, 60. And then you get that number 16 minus 19, of course, is negative 3. When you do a multiplication, you'll have that answer there. When you do a division, 23 divided by 20, it's 1.15, and you have things like that. That is more of like a vector, right? And again, even so, let's see. Vector, let's call something maybe vector 3. Yeah. How about if you want to call a specific index. Yeah, I want somebody to remind us what we covered. So I want to check which number is belonging to index number 3. Of course, you can see it, but write a function that returns the number that is present in vector number 3. In index number 3, I mean. A reminder. Hello? Eric, maybe you can remind us. These are things we covered last week before we move to something on how to create a matrix.
You square bracket, then you write.
Tell me, I'm starting. So I want to save it as vector number 3. Next.
You square bracket.
So I start with square brackets. Or which one starts? Yes?
Pass.
Oh, okay. Continue, Eric.
Pass.
Collins, you were there last week. These are things that we did last week. Eh? Okay. So maybe we add it as V1 and check on maybe what is occupying. Sorry, what have I written? Okay. Oh, yeah. I thought it's a subtraction. V3. So you can see I'm checking on a specific vector occupying position number 3, and then it returns to me that it is vector number 67, right? Yeah. Suppose I want to see which vector occupies position number 1 and 5, right? So there I will be introducing a concat function. Yeah. Vector number 1 and 5. Yeah, and these are things that we covered last week. So you can see vector number 1, 23, vector number 5 is 16. Yeah, and it returns. And even you may want to see another one occupying position number 3. You run it there and have your answer. So this is just what we call vector subsetting. It's called subsetting. So if you want to look up for more information, just go and search how to subset. And it's basically all those things that we covered. So that is for those having a problem understanding what vectors are. I can change it to matrix and say this should be matrix, mat1. Maybe let me say mat1. And here, of course, I'll change it to matrix, right? 23. This, of course, has to be so this is 23, 34, 67, 45, 16. That is 5. Maybe we add another one to be something like even 34, 38. I mean, and then we say n row, that is number of rows, is equaling to 2. So if you have 2 rows, and then maybe we are supposed to arrange it by row equaling to true. by row equaling to true, something of that sort. I can just basically copy this and overlay it here. And maybe and another maybe 56. Number of rows to be equaling to 3. By row, we are arranging it by row to be equaling to t. So you can write t or you can write true, but you cannot write true of small letters, right? You see, it will change it to you so that it becomes that. So you can run that, and then you can now do even a, oh, sorry, this one is supposed to be mat2. Yeah, things of, you can also do here subsetting and try to see what is the component of, let's say mat, or maybe x to be equaling to mat1. And now subsetting, you use the square brackets, right? And if I do that comma, what am I supposed to be seeing when I run this? What should be the answer when I run this line? What should be the answer if you run this line? Ronnie, what should be the answer?
I've just logged in. I'm trying to catch up, please.
Yeah, but you should be able to figure it out from last.
Let me look at it.
With the third eye. Who is ready to take us through that? There's somebody whose hand is up. Did somebody raise the hand?
34.
Oh, you should be getting 34.
Yes.
So x 34 16, right? What does this mean? Let's print mat1 so that you see what it means. So it is giving us the second column, right? All the values that are appearing in the second column, which is 34 16, 34 and 16, right? How about if I write maybe 2 2? If I write not 2 2, 1 2. If I write 1 2, then it is going to return for me the value that is in there. Of course, matrices are always in terms of row times column, RC, row times column. So if you have here mat 1 2, then it means that row number 1, column number 2, and row number 1 is occupied by values such as 23, 34, 67. Column number 2 is occupied by 34. So that is subsetting. Here we are not using that C because rows we can declare it by R and C. I mean row times column. We can have it as one joint thing compared to vectors. That if you want to see values occupying two positions, not really two positions, two different positions, then you have to include the concat, right? But in vectors we are not doing that. Okay. Let's in matrices, let's try it out and see what the answer is. 23 45, 23 and 45. So that one is, it's basically returning for you entries in, 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, 23 and 45. So that one is, it's basically returning for you entries in 23 45, in the first column, right? Let's see maybe 2, 2 and see the difference. 45, 45. What is the value in 45, 45? The values present in 45, 45. So that is row, more of like row 2, column 2. Should it be row 2, column 2? Or we are having 45, 45 printed twice? Yeah, so that is where the complexity of using, let's try to remove this one and see the value. In this case, when you have it as 16, that is row 2, column number 2. Row 2, column 2, 16, right? If you use the concat, yeah, we are having a 45, 45. Let me try to see what it means. Yeah, I don't know why it's reproducing 45 twice. Yeah, so if you want to maybe do a subsetting in matrices, you can use this. Or if I have it as 2 this way, then it means I'm supposed to be producing all the entries for the second row, which is 45, 16, and 38. The second row is here. So that is subsetting in matrices. But there are other things that you can do here, like multiplication. I think we talked about quite a number there. Multiplication, division. So suppose maybe you want to divide mat1 and mat2. You can just be writing that non-conformable arrays. Oh, we can't do the division because they are of different dimensions. For example, mat number 2 is a 3 by 3. Mat number 1 is a 2 by 3. So we can't do unless maybe we add another entry here. Maybe add 56, add 78, and add 3. And then now rerun. And then run this one. That one, non-conformable arrays. Okay, let's print. Okay, the issue is here. I had it as 2, while it's supposed to be 3. Okay, now we have it that way, and try printing. Yeah, now you can see it's dividing, right? So the issue is here where we still add number of rows to be 2. So it has to be of the same dimensions, right? Either same number of rows, same number of columns, or yeah, that is what you have to check for you to do the division. There is that question about multiplication that we gave out, that you can multiply a vector, a matrix by itself, right? Some people are doing this division. There's a division that is not really division but multiplication. Maybe multiply mat1 by mat1 by mat1. So who can explain what this result is? Of course, you know mat1 has these values 23, 45, 56, 34, and blah blah blah. So if you multiply mat1 by mat1, or even let me say you are multiplying mat1 by mat2, who can explain the result that is going to be, or how that division is going to happen? Let's start with Wamboi. Is there somebody called Stella? Stella.
Yes.
So how is this multiplication going to happen? There are two different kinds of multiplication that can be used in R. But now this is 1. Or we can just run it. Let me just let me first run this one. So that you have 23 and 20. You have 23, 20, you have 34, 18. So how this multiplication is going to happen, let's first run this one. And then you can see that there is a result for 60, there's 612, there's 1139. So what is happening is we are multiplying the value that is in row 1, column 1 by the value that is row 1, column 1 of the other matrix. So for example, here it is taking 23 times 20, getting you for 60. And then to get 612, it's taking 34 multiplying by 18. Then it is getting 612. And again, you can check maybe 67 times. So it is multiplying it positionally. 67 times 17, and then you get 1139. There's this matrix multiplication. There's also another one where we are multiplying mat 1, of course, by mat 2. So there's this one where we are using even the percentage, the percent sign, right? And multiplying by, and then you see now you have completely different answers, right? Here we have 3851. So here what is happening, it's that multiplication that you used to do in high school. You are taking all this row 1, you are multiplying row 1 by column 1. So you are going to multiply 2334 times 20, 15, and 43. So 23 times 20 plus 34 plus 15 plus 67 times 43 is going to give you 3851, the first value. So it's more of picking this and then multiplying by what we, sorry, of course I can't highlight it, but it's picking everything that we have here in the first row, multiplying by this. Yeah. Again, it will pick first row times second column, right, to get you 5750. Again, first row times this last column to get you 6795. Then next, it picks 15 and 1978, then multiplies by, okay, it picks the 45, 1638, and then multiplies by the first column, sorry, then multiplies again by the second column, third column. Yeah, so it does a summation as compared to this other kind of multiplication, this first one, where it is taking 23 and multiplying by 20, 34 multiplying by 18, 67 multiplying by 17. I hope that difference has been understood. Press a like button if you have understood that difference. Yeah, Victor. Who else? Kasola and Koitoi. The ladies, Stella. Kesi Mwendo. Emmanuel. Okay, yeah. So that is another difference when it comes to matrix multiplication. So which one would you prefer? Which one do you prefer? Eric, which one makes more sense?
The second one.
And you, Evita? Evita, your microphone is on mute. Which one do you prefer? Victor, which one makes sense?
I think the first one.
First one. Yeah. Now here is a debate. Somebody else to chip in. Which one makes sense? Pashamai.
The first one.
Okay. Yeah, but matrix multiplication. This one is the one that we use. Right. This one, the second one that we are working with. Not taking 20. Of course, in high school, see, I believe for those who are in high school, back in the year 1999, we were using 23, 34 this way and multiplying it with a chini. So we take a row times column. Matrix multiplication is always a row times column. So if it's first row, multiply by first column, multiply by second column, unless maybe curriculum changed somewhere in 2006 after we were out. But I believe it should not be the case. Another thing, I think that was just maybe a little bit of a sneak peek into what we did last week with the vectors and matrices. So, who raised this was, I believe it was Pashamai. You are the one who raised this. So you can go in depth and find out more about subsetting. Yeah, this is just an introduction on how you can write a matrix or a vector. But of course, you can also include dimension names, right? Yeah, and add their list and whatever list it is. So maybe row one, you'll call it as some names, and you'll give it the names that you want. So how can we call maybe the first row for somebody who has any, like the rows? What name do you want us to give to the rows and the columns? So you can check out on that so that you get to understand how to work around even naming of matrices, because I believe that is something that we covered last week and it was covered sufficiently. Unless there's somebody who really thinks that we need to look into how to name the rows and the columns of a matrix using dimension names. Anybody having a problem with that? Yes? Yeah, that one, I'll leave it again for you to even go back and look into it. Something else that was there in your assignment was also, how can you find the determinant of a matrix, right? And maybe save it as y, determinant of a matrix. And then now you can say what is y. Maybe we are being told it's negative 63 point blah blah blah. That is a determinant. So you can also find determinants between matrices. You can get squares and you can square, you can get a square root and things like that. Okay. Yeah, today we are supposed to talk about something called pipe operator in R. Have you ever heard of a pipe? Or what do you think a pipe does? Have you ever heard of a pipe operator, Stella?
No.
Eric, or anybody else? Nathan, how are you doing? Yeah, so we'll talk about that. And again, there's something that even part of the assignment that you are given, you could even use the filter function. Yeah, you could use the filter function to filter those columns that you are supposed to return, because there's that assignment that was telling you to return. I believe it's MPG or something. Let me look at one of the assignments that somebody did. I think let me see what the exercise was. That using empty cast dataset in R, create a data frame that only contains the column MPG cylinder, and I believe this should be something. Let me see. You can try it out even using the filter, so that you see that you're able to get it. So that is weight. So WT. So you are supposed to return columns that return data frame that only includes MPG, cylinder, and the weight. You'll try it out with the filter. So what I mean, you can also filter data sets inside R. So for example, if you look at empty cars, here we have MPG, we have the cylinder, we have this is a column. This is displacement. So displacement, we also have that, and maybe you have even the gear, the number of forward gears, 4 and 3 and 5 being the maximum. So you may filter so that you only see data for vehicles that have 4 gears, or maybe that have only 3 gears, right? Or that have 5 gears only. Yeah. That is where you use now the filter function. We always have a filter function called we have a function called filter, which you can also use to filter your data. Let me see if we have that student's data. Okay, I missed a name that you saved it using. But now we suppose you want to say to filter that data so that we have only showing us only 4, like vehicles that have only 4 forward gears. So write the name. Maybe this one you can even give it a different name. Filtered empty cast just makes more sense, so that you know what you're talking about. But the main thing that you need to understand is filter here. So filtered empty cast, maybe you give it something like even X, but I'll get it back to filtered empty cast so that you know what we are dealing with. So the moment you type filter, and this is the best function that we have, filter. It's a dplyr, it's in the dplyr package. So before even you type this one, load first the dplyr package, or load the tidyverse. Tidyverse contains dplyr, contains ggplot, contains string r, contains par, I believe also that contains also something else, readr, if I'm okay. Yeah, so tidyverse. So you can load first tidyverse, and then now you start typing the filter function. So suppose you want to filter, you can see here data. The filter function is used to subset a data frame, retaining all rows that satisfy your condition. To be retained, the row must produce a value of true for all conditions. Note that when a condition evaluates to NA, the row will be dropped, unlike base subsetting with this. That is just more information on that. First, you can see here data. The first thing that you have to write is data. So the data that you want to filter is empty cars, right? Then you have a comma. So you want to filter it by which row? We want to filter it by, not really row, but column of gear. Then you write there gear. So if you write gear is equaling to 4, we want to see the information about vehicles that contain or maybe have gears that, the forward gears that are equaling to 4. If you run it, you will see an error. We detected a named input. So this usually means that you have used just one equal sign instead of a double. What is the difference between this one and this in R? Somebody's to get us the answer very fast. One equal sign and two equal signs. What is the difference? Victor, do you have any idea?
I think one is a assignment.
And the other?
The other one is it a logical? No, I've forgotten the other. Sorry.
So when you have it as 2, it's more of like strictly equaling 2. But the other one you were talking about, yeah, it's an assignment. This one for strict equality. So gear that is strictly equaling to 4. And if you run it now, you can see that there is information here. So check on this gear column. Gear column. You can see that all the gears need 4, right? And that is something that you can now see. Suppose you want maybe gear is equaling to or greater than 4. What is it telling you? Error is disabled. Set R use pipe and whatever to enable it. So how can you write the is greater than or equaling to? Somebody to tell us. These are part of debugging that you will be doing. So the first one it gave you when you have just one, so that you ensure that at any point in time it's 2. Now that you debugged and got the answer. Now how about when you want to get like a gear that is greater than or equaling to 4? Any answer? Somebody to volunteer themselves. Let me pick somebody. Kasola. Kasola. Kasola is not speaking. I believe it should be this. Let's run it and see. So that is your answer. For those who are not aware of what we should be doing there, so greater than or equaling to, right? So if you write it this way, you'll be having a different thing. You'll be having an error, right? If I maximize it, okay, yeah, you can see input 137 and things like that. So the correct way that you're supposed to be writing that is greater than or equaling to 4. So our entry here, you can see gear 4 and even gear 5. So 5 is also here. So greater than or equaling to 4. Another thing, or even if you cannot figure out how to write that, somebody might write it twice and then say or operator, we use that or gear greater than 4. Let's run that and see. Sorry. And okay. Strictly equaling to that, or and then filtered empty case. Yeah. So you can see, if maybe it's difficult for you to figure out, you can say gear is equaling to strictly equaling to 4, or gear is greater than 4. But that will really be too much writing. You just have it as this. That is filtering. You can have multiple conditions. I've for example shown you like the or. For you to write maybe or, you just use the stroke. Is it stroke or that straight line? For you to write and, you use this one. So that is like those two conditions has to be met, right? So for example, let's say that the gear is greater than or equaling to 4, and also the cylinder, let's say, and cylinder is greater than 4, or maybe is equaling to 6, or let's say greater than 4, greater than cylinder greater than 4. And now if you filter it, you can see for cylinder greater than 4, you can see up we have 6, also we have some sprinkles of 8. So gear is greater than or equaling to 4 is here, cylinder is greater than 4. So if you use maybe equaling to 4, we'll have a different value altogether. So here we are limiting 4. 4 is not appearing unless we add the equality sign. So this one. So you will see. Also, of course, cylinder. There is no cylinder mentioned as 4, so that is not a problem. Yeah. So this is it. How to filter. Anybody who is having a problem with filtering data? Shout it out so that we see how to help you out. So this is a case where you are having multiple conditions. When do you use double? This one. When do you use? There's a time when you are supposed to go and research on when you are supposed to be using these two, right? Yeah, instead of one. So part of that is your assignment. Tomorrow, the first thing you are going to say in class. Pashmai, are we together?
Sure.
Okay. Mudoni?
Yeah, we're together.
Okay. Korir. Yeah, Emmanuel is also saying yes. Mwema. Okay. Mwema is also fine. So that is filtering data. So kindly, if you have any problem also in mastering what filtering is, kindly go and look for more information again on this. But I've just tried to break it down. You can even use a different data set, for example, like diamonds. Yeah, you can see what diamond and Stella, in your operations or maybe in the assignment that you are doing, you are writing diamond instead of diamonds. And that's why I asked you to send your R script so that you even see it if it is running. All right. So the diamond is different from diamonds. Diamond is a Tanzanian. Diamonds is an R script. So let's see diamonds and see what you can filter. All right. What can you filter here? Anything that you may want to filter. So you can view it. I want somebody to tell us what we can filter. Then we filter and go. So you have this as your diamonds. It's a large data set, right? Large or huge. So anything you want us to filter? Ezekiel.
Yes, I've just come in now. I'm trying to follow.
Ronnie. Your microphone is on mute. Okay. So you can check on what you may want to filter here, and you can even filter maybe X is less than 4.0, right? And see all that data set, right? Or X and Y are less than 4.0, right? That is something that you can filter. Or you can filter something like check on the data set called iris. Iris setosa. Is it setosa or setosa? So you can also view iris. So iris. So you can look at all this data set and maybe filter iris and say you want to filter data set that is iris. What you want to filter is species. Let me see. So species is equaling to setosa or what? So there is setosa and also there is versicolor and virginica. So here species is supposed to be equaling to, let me see first this. Yeah, so this one is a string, sorry. Why we are writing, that's something that you might also take a look at, basic color. So why is this one not giving us the answer? Can you check if this one is going to work? Which one? Okay. Yeah. So filter iris. So it's saying 0 rows. Yeah, it's 0 rows because there's all of this word cannot be found. But you want an instance where the species either setosa or vesicola. Okay, so here's where we can have that long function that you are looking at. Species or species is also equaling to vesicola. Can you try to check also if you can use the concat to get you the answer, vesicola, and then filtering out. Yeah, so this one is the information that you want. So you can even click here and say view filter iris and run it and see that we have omitted virginica. We had virginica here. Yeah, from number 101 up to number 149, 150. So we have omitted it. So that is how you can do your filter. But check on how you can simplify the whole of this. Anybody with a question? You can even do filtering with other data sets, like even that sleep data. There is the sleep data that you can also use and see what you can filter it with. I mean, there's sometimes when filtration is required. Filtering, sorry, not filtration. Filtering might be required. So here, of course, there are two groups. You can only filter to maybe remain with one group. So you can practice around with that. Are we together? Or I have complicated things? But I believe that is what we were doing some minutes. Bashamai, you are saying that it seems like your library doesn't have which package? You can just unmute and say.
Tidyverse.
Sorry?
Tidyverse.
Tidyverse package. Package. Yeah, you need to install it if it is not there. Just run here, install .packages, and then have it in quotes this way.
Okay.
Yeah, you will find it, and then practice that filtering. Let's go to something else. And here now we are going to be talking about a tool called pipe operator. Here is where we introduce something called pipe. and pipe hapa sasa si ya kuchapa watu, but pipe is this one. So initially ile multiplication ya matrices was this way, but right now we are changing that asterisk up and replacing it with this. So what is the pipe operator? So you can see even from the what I wrote that a pipe is a powerful tool for simplifying and chaining together a series of operations or functions in a more readable and organized manner. In a more readable and organized manner. And pipe operator is found in the dplyr package. That's why here. So if you run tidyverse, what I ran here like library tidyverse, you don't need to run again dplyr because dplyr is a component of tidyverse. I hope that is understood. So and either way you can just run dplyr. So this is like we want to do a filtering and summarizing data using the pipe operator. Suppose now maybe I've shown you the iris data that we had here, or we can just view it once more. So there's this data, and now we want to filter and summarize data using the pipe operator. Of course, we've done some filtering on that and produced filter iris. But now suppose you want to filter where the sepal length is greater than 5. The sepal length here. If the sepal length is greater than 5, the value will be returned, or the data will be returned. So you can save it at something as maybe result 1, right? So the first thing that you have to specify is the data that you're using. So it is this data that we want to use the pipe operator on. Now you pick that data and then we want to chain some series of operations. So number one, the first thing we want to do is to filter data. After filtering that data, we want to summarize it by getting the mean. I hope you are getting where we are coming from. The first thing we are starting with is data that we want to use. We want to filter iris data to get the sepal lengths that are greater than 5. Now, after getting the sepal lengths here that are greater than 5, or first let us get that information before even getting this summarize, so that people don't get lost. So let's filter first this, control enter, and then we can even view it. So we've filtered, and here you can see sepal lengths that are greater than 5.0. You have here 5.1, 5.4, and you can see even setosa, we have information for them up to here, number 22. Vesicolor is also there. We have some data sets that some sepal lengths that are greater than 5.0. You can also see vaginica here. We have the information, right? We have all that information. Sepal length, we also have sepal width, and that's such like stuff. So that is step number one. We have done just filtering the iris. This same thing, we could have done it with just maybe save it as result 2, right? And use the filter function that we did, filter. And which data are we using? We are using iris. And what do we want to achieve? We want to achieve sepal we want to choose sepal.length greater than 5. So what I have here, it is what we have here. Yeah, I can even run this. Let me first just include view it first and run it. You can see that this information that we have here, actually we are ending at number 118. This one also we are ending at number 118. Result 1 and result 2, they are the same thing. What we have in this line is the same thing we have here. We have in the first line here. Okay, I hope we have understood. But now we can use this pipe operator that we were working with to chain the operations that we are doing here. So after this sepal length, we want to chain something else, and that is we want to summarize this information that we have received here. We want to get the mean. We want to get these means, right? The mean by sepal width. So you can see that we want to summarize the mean of sepal width. So if you run that entry, you will get 3.048305. That is the result that you are going to get. That means it has added all these values that we have here, 3.5, 3.9 up to the last one, 3.0, then divided by 118. So that is what we have. So 3.048305. So the first thing that we have done is taken iris data. Using pipe operator, we have filtered it, right? After filtering by sepal length greater than 5, then we have summarized the filtered data that we had. We have just summarized by getting the mean of sepal width, right? We could even get the mean of, let me first remove this. We could even get maybe the mean of maybe petal width, right? We just come here and change. So summarize mean sepal, petal width, If you see, you can see 1.432203. Somebody might be requiring a minute to digest that. Who is the person? Are we together, Victor?
Yes.
Mwema? Eric? Okay. Eric, anybody who is feeling lost, just put a thumbs down. If you're feeling okay, put a thumbs up. If you're feeling there's something that needs to be repeated, thumbs down. I want to compare the thumbs up, and so Ezekiel, okay, Andra, Collins. So no thumbs down, eh? Ross, are we together? Ross is not with us. Rose, kindly tell us where you are feeling lost. Tell us.
Mine, I'm an error. Yes, I don't know where I'm missing.
Can you take a picture, or take a picture and post in the group, or you're using your phone?
Mm.
So that we see it quick, fast, minus slow. Before we go to example number 2.
I post in the on top.
Yeah, sure.
Yeah.
So let us check Ross code, and somebody can say where the error is. Let me give who wants to be given a chance? Who has seen the error? Yes? Of course, I've seen the error, but let me ask somebody. If Koitoi, are you seeing the error with Ross code?
She has put three brackets, closing brackets instead of 2.
Ross, can you try to change that? Let me check again. Try to check the number of your brackets.
Even if I do 2, it's still giving me an error.
There's one bracket that you need to add at let me see, sepal length. So iris. There's a bracket that you need. Oh, okay. Mine, I was using 3 because of maybe this view that. Let me remove this view because it's distracting you. Anytime you click on the first bracket, you can see that it is matching with this one. If I click on maybe this second bracket, it is matching with this other one. So let me remove this one so that it doesn't mess you out, so that it remains that way. So yours, the issue could be on simple length. So even if you remove that second bracket, it's still saying an error.
Yes.
So what is the error? Like, what is the error reading if you remove the last bracket? What is the new error?
Object sepal width not found.
Sepal width. But it should be. No, it's because.
Petal, I've seen.
Yeah. Okay.
It's supposed to be petal, not.
No, even if you use sepal width, there is no problem.
Okay.
But it's because you are not using pipe operator. For you are not using pipe operator. for example, line 563 and 564, there is no link between the two.
Okay.
You understand? Are you getting what I mean?
Mm-mm.
You're not getting it. Delete that, the whole of that, because we are not using filter here. You're in result number, you're in 563. We are using pipe operators now. We are not using the filters at this point in time.
Okay.
Line number 563 is going to run, but line number 564 is not going to run because it does not know which data you are using.
Okay.
Right? Line 564 is not attached to line 563. So 563 is going to run because it knows the data you are using. But 564 is not going to run because it does not know the data. So if it can only run if you write maybe summarize in bracket iris, right?
Okay.
So check again, compare it with this one that I have here. The results, of course, I have maybe iris and then piping it to filter, sepal length and blah blah, then pipe again, summarize mean petal dot width. So yours, there is no link between 564 and 563. And even if it could be any link, then you have to change this filter and just type it the way we have written this other one. You can compare it with 562 and line 462 up to 464.
Okay.
Yeah, redo it and you can check again. And another thing, maybe you can look at another example. And here now we are doing a chain of multiple data manipulation steps. So we want to filter, then arrange, and then select specific columns. So you can use this pipe for even 30 lines of code. Of course, when it becomes 30 now, it is really confusing, right? But I mean, piping, using pipe, it makes your code really understandable, readable, and presentable. Maybe if there's something like that. So we can have the first thing, empty cast. Now we want to use the empty cast dataset. And I believe that you've interacted with empty cast for ages now. If you want to see what it contains, is just view, tab, empty cast, all right? And then control enter. So this is the empty cast that we have, right? We've used empty cast now for quite some time. Okay. So we are going very slowly, slow with this, so that you don't lose out on something. Now suppose we want to see the MPGs, right? Miles per gallon that are greater than 20. Cars that have a miles per gallon, is it a miles per gallon? Yeah, miles per US, yeah, per gallon, yeah, here. That is greater than 20, right? So the first thing we want to filter MPG for those that are greater than 20. First, we can maybe remove this. Control X. Let me Control Exit, and then run it, and then view, print result 2. So if you see here result 2, so you can see here 21.0, 20 blah blah. We have all this information of cars that have a miles per gallon that is greater than 20. Let's go back to it again, step by step. Now we want to, after having this data, right, we want to arrange it. Arrange it maybe from the descending to ascending, sorry, from the smallest to largest, or the largest to smallest, whatever way. So we want to arrange it again using just that column of MPG, and now in a descending order, right? So you can see here what we are writing. Let me just remove this again. Now we want to arrange. You can use this arrange. Arrange is also another function in dplyr. So you can see again here that arrange, you have to specify the data. But of course now we are not going to specify the data because we had already written the data that we are using here to be empty cars. So all these other operations that are going to be happening here is going to be based on empty cars, right? If you were to write that arrange function, it could be this way, and then data empty cars, and then now you specify, maybe you want to arrange it by the MPG, right? Yeah, this way, right? So for example, here you can see it has been arranged in ascending. 10.4, we are ascending going up to 33.9. But now we are not going to specify the data because we have it. We have the data that we are using here to be empty cars. So we are just going to arrange it in descending order. If you write it arrange and then in bracket MPG, it is going to arrange it in ascending order. And you have seen it with the arrange function that I've done, right? Are we together? Okay, let me first do this and then you can print. Yeah, Victor Sangoro is clearly following. And then, so if you arrange it, you can see that you have 33.9. We are descending up to 21.0. The last thing that we are looking, we want to select. We want to just see specific columns, right? Which columns do you want to see? You want to see, because here you can see we are seeing even nonsense like these ones, the HP, DR80, like we are carrying all the garbage. So you can write that one and then print, and then you can see that we have MPG cylinder, and then HP is there. And then we can even go ahead and say, let me see, even before that select, we can even go ahead and say maybe group by, what are we grouping by? Group by something like cylinder. Because you can see 6 is hanging somewhere here, 4 is hanging here. So we want to see the force first and then 6. And then after doing that, and somebody needs to tell me the shortcut of the pipe operator. You need to also know that. Then we do that, and then try to run it. Or we are not going to get any error. And then now you can see, sorry, it was supposed to be arranged by the cylinders. Oh, okay. I know what it has grouped. So this one seems to be coming from the same data set, from the same type of car. That's why it's grouping 6 and then 4 and then goes ahead to group these other ones. So that is it. That is how to use pipe operator in R. And that is something that makes your code really understandable. You can even see now the steps that we have taken here. If you are to write just one whole line of code, it will really be complex, right? Yeah? Are we together, Ezekiel? Ezekiel?
Yes.
Are we together?
Yes, yes.
Okay. Thank you. How about Anjeru? Tiamo Anjeru? Anybody who is feeling lost, thumbs down. If you're okay, thumbs up. Kasola is there. How about those who are not putting up their thumbs? Go down. Ronnie? Ronnie, are we together? Together. Korir? Evita? Evita is also okay. Okay. Let's look at another thing. Now you can also use a pipe function to create a new variable, but again there is this function called mutate. Mutate is the function that you use for creating a new variable. So this is just a simple thing that you're doing here. And of course now maybe this is our third result, and now we have again iris, then the pipe, right? Then we want to create a new variable which calculates the sepal area. And then the sepal area is going to be given by the length times the width, right? So let's first chunk out this. Yeah, so result 3 iris and blah blah, and then mutate sepal area is equaling to the sepal area is equaling to sepal dot length times the sepal width. So let's first see iris, and then you can see iris has a column called sepal length and also sepal width. So you can take sepal length and sepal width and multiply it so that we get a new variable and call it sepal area. So if you run this, one, control, and then print the result, you'll see that we have sepal, we have a sepal area that has been created. 5.1 times 3.5, 4.9 times, it just, okay, 4.9 times 1.4, and it has given us the first 6 because we have printed, we've used the head function, right? So head, if you just print all of it, you can see up to 150, and then you can see the sepal areas of all of them. So after doing this, we also maybe don't want to see all these things. We may just be interested in seeing the species and the sepal area, right? Control V, and then get me back to the species and then the sepal area, and then you can print the result and see that we have the setosa there and all the areas, and versicolor you have it there, and then you can even go ahead and arrange or group by. Of course, it has been grouped by. Let's see. So the first thing we may want to, of course, it's group by. After grouping it by species, and then arrange by the sepal area. And then now you can print result 3. Let's, instead of printing, let's view. Why is it not arranging what you want? View result 3. And then you can see there the highest is 10.0. Now, are we going? Oh, we are arranging it in ascending order. So 30.02, 29.26, up to going back up to 10.0. So if we add here, maybe descending, then it will just reverse what we have there. Let me remove this one and see what. Still, it's just similar. Okay. So that is also another thing. Using mutate to create a new variable. Focus is on this. We have done select, and we have even done arrange previously before. So focus is on this new thing. Okay. Let's go to something else. Group data, and of course group we've also done. Even group by here. Let's summarize and then arrange. So the first thing we have now is empty cars. Group again data by, we want to group it by cylinder. I think this is what we wanted to achieve in this section. We should have done. So you have to also check on the sequence. So this one should have come a little bit earlier before arrange. But let's see what the result is here. So this is the same line of code that we had up here. So let's try to run it. There's no need to now cut it into chunks to explain, because I think you have understood the whole process now. So you can see what has happened here. It has grouped all those ones that have the 4s, the ones that have the 6, and the ones that have the 8s, right? And grouped it and summarized and arranged, and now you have the result here. Are we together? Somebody to ask a question. Any question? Okay, then it means we are following through. That is my belief, that we are following through. Another thing now, again, you can even look at how you can now use the dplyr functions. All these things that you are doing are in dplyr, like the summarize, the arrange. That is now what we call data manipulation. And I think I mentioned it when I was talking about what dplyr is, that it is used for data manipulation. So you have seen how we have manipulated this data. We have summarized, we have arranged, we have grouped, we have filtered, right? You have selected. What else have you done? Yeah, we have done yeah, I think I've mentioned all of them. Now you can even combine all those things that you've done and then generate a ggplot, a plot for it can be a what? It can be a bar graph, it can be a column chart, it can be anything that you want to see. So let's see here. So first now we have empty cars, the empty cars, right? You are filtering. Of course, this one we had written. You are filtering. You're filtering the the data set so that we have only mile per gallon that is greater than 20. I think that is the first thing that we did. If I remember, yeah, number here, what we did here, and then after filtering that, then now you are going to introduce ggplot. I also need to tell you how ggplot works and how. Let's before even writing that, let me show you what ggplot is. So how you can build a plot with ggplot, it's always like this: ggplot, and then you can see data, and then mapping, and all other things that we are going to talk about. So the first thing that you have to introduce is maybe data is equaling to empty cars, right? And then say that I want to build maybe something like a geom bar graph, geom bar, right? And then I'll come here and say mapping. We are mapping it to an aesthetic. And what is going to be in my X column, right? Let me look at what empty car has. Maybe I want my X column to be something like, let me say an example like MPG. My X column is going to be MPG. And what is going to be my Y column? So this one, a bar graph, we cannot print that. We can write maybe geom scatter. Geom point, sorry, is going to generate a, and then Y, my Y is going to have something like a cylinder. Let's try to run this one. You can see the plot that has been made here, right? So this is basically how ggplot works. Let me show you why I changed the bar. Let me say that maybe I've written this. You can see the plot is not plotting, right? That's why I quickly changed it from bar to point. I had foreseen that. So if you do a print of that, you can see all the values that are in fours of cylinders that are 4, and then the 6, and then the 8. So this is the basic outline of how plotting in ggplot is, right? So you first declare what the data is. Sometimes you don't have to write that data is equaling to. You can just leave it this way and say that it's ggplot empty cars, right? Plus geom point. It will automatically figure out that this is the data. You will find also some people writing it this way, ggplot empty cars, and then all these things that I wrote here. Let me just copy it and paste it here. And then just write, geom point. This one is supposed to be having another bracket. And then just write geom point this way. It is still going to run, and you can see it's plotted here. So mapping is equaling to aesthetic. Then what is going to be appearing in our x axis and what is going to be appearing in our y axis. So you can see there, and even maybe, yeah, this one. So this is the skeleton of ggplot. Now let's go back to this, right? So here, you can see that what we are filtering first, we are using empty cars, and then filtering so that we have only MPG that is greater than 20. Yeah, just as we had done. And then now piping it to a ggplot, right? Now we want to plot something. Then here we say aesthetic. You can say aesthetic, or you can even add here mapping is equaling to aesthetic. No problem. Sorry, Control Z. Yeah, mapping is equaling to aesthetic, or you can just leave it this way, aesthetic, and then a bracket X. We want to use maybe WT, this weight. And then for the Y, we want to use the MPG, this column. And then let's leave out this Control X. And then now plus geom point, the same thing that I did for you here. Then geom point. All this information, we could have added it inside here. We could have just left it this way and then added that information inside geom point. So let's first plot this one. So you can see what is happening here, right? You can see WT here, and you can see the MPG up, and then there's that plot. So sometimes you want to give this plot a name so that you don't leave it this way. Iachi kama yatima. And then that is where the label come, the labs. The label x-axis, let's label it as weight, not WT. Y, let us label it miles per gallon. And then the title of the ggplot, let us give it scatter plot of MPG versus weight. And this weight has been filtered. So let me even add filtered greater than 20. Or just say filtered greater than 20, right? So let's remove this, Control Z. Let's remove this one. So you can see now here it's weight, here it is miles per gallon. If I add that label, you can see here now we have scatter plot of MPG filtered greater than 20. That is, now you have combined ggplot and dplyr. Anybody having a question? Have you understood? It needs a review, by the way. Victor, are you okay?
No, I'm floating. No, you pardon.
Yeah, now I expect that somebody might be floating. Who else is floating? Let me get the number of people floating. Emmanuel Korir. Anybody else? Eric? Yes, Hubert. Hubert is floating. Evita. Anybody else floating? Casey? Casey, just raise your hand if you are floating. Or you can yes, Kidole, if you are okay. Because your microphone is not working. Or you can type. Casey is okay. Now let's go back to this. Up to this point tulielewa. We understood. Let me remove this. Up to this point we understand. Yes or no? This I'm talking about this bit. Let me control X. These two things you understand them. Yes or no? Hapo tuko sawa. Okay. Now mambo imeharibika wakati tumeleta ggplot. So I told you the general outlook of ggplot, right? That
Please start.
sorry?
Start.
I start from the outlook of ggplot.
Yes, they are empty cars.
Okay, let's start from this one. And let me remove it. So the moment you start typing ggplot, let me tell you the simpler one. So data. So you have to first declare which data are you using. So I am using empty cars, right? That is first step. But also I said you can even work without saying data is equaling to. But let me just use data is equaling to. Data is equaling to empty cars. Yeah. And then plus GOMS. So how ggplot plots data, it's using some geometrics. These things that we call geom. So there are several geoms. There are geom area, bar, box plot. You want to do, actually you can even use geom box plot so that you see what is there. Geom box plot, and then you can say mapping is equaling to aesthetic, then another bracket. What are you printing on the x-axis? We are printing is equaling to cylinder. What are we printing on the y-axis? We are printing similar way to how you will print. Why am I saying print? How you'll print a scatter plot. If you built it in Excel, or you built it in Python, and then why maybe you want that MPG. Yeah, let's try and see what is being returned for us. You can see maybe this is the scatter plot that has been printed. Yeah. So this is the general outlook. You first have to declare your data and say that you're using empty cars. You have to specify which geom do you want to plot. I want to plot geom point. Okay, point, you can geom point, you can build scatter plots. Geom box plot, you build box plot. Similar thing to what you have printed here. Geom bar, you print bar graphs. Geom, let me show you another. Geom histogram, you build the histograms, right? For somebody who wants to build a histogram. If you want to print, what else? Line, geom line, right? You can use a line graph. You can print this one. Yeah. Let's try to see if it can, it's printing. But this is funny because it's really not something that you can print using geom line. You want to print which other geom? There's an instant where we are going to use geom jitter, but geom jitter cannot be used by aesthetics. We'll talk about this one. So geom jitter, geom smooth, and things of that sort. And lest we lose track of what you're doing, let's talk about this one. Geom point, you've seen what you have printed here. Now, let's go back to these things that we have over this side. Even this one, you can add it. Yeah, Control P. Similar thing that we have there, we can even write it here. So we have this ggplot. Whatever I just wrote here, it is what I can lift and place here. But then I will need to remove empty cast because already I declared that you are working with the empty cast dataset. So ggplot, and then the only thing that now we are talking about is that aesthetic, because I also mentioned that you can have this mapping is equaling to something. We have it inside here. We can have it inside here, right? So that you just remain with geom point and all those blah blah that you have. So this, whatever is here is what we have in this line. Geom aesthetic x is equaling to wt plus all those things. And then now you have geom point, right? What I have here. You can have it as geom point. Then plus labs and all. Labs is just labeling. We want to label the x-axis as weight. We want to label the y-axis as miles per gallon. And then now you give it a title. For this place, we are not using pipes. We are not using pipe here. If you use pipe in this place for the ggplot, you are going to mess. Let me just show you. Are we going to? Okay, let's try it out. I might be saying that you're going to make an error and it's not going to make. Let me check it. Yeah, now you see there are these errors that now comes around, right? So for these ones, you use the plus, right? And then filter, the only way, so empty cast pipe, we want to filter it, and then after filtering it, we are passing that information to ggplot so that it can print for us a diagram or a map or anything that it needs to print. So that is just how you can you can print using ggplot. But here you don't add these pipes between after these pluses, and because ggplot uses those plus. You can have a look at it in depth so that you understand where we are coming from and where we are going to. So I hope you've understood how ggplot, how you can plot using ggplot, and then now how you can just lift all this thing and place it here, but now remove empty cast. The only thing we are removing here is only this one because we already have it here. And then we are not using it because we have filtered the data. That is now why we have ggplot without empty cars and things like that, because now we are using a subset of empty cars. Praise the Lord. Are we together? Actually, now you see how R is now becoming beautiful. Yeah, Emmanuel Correa is now really getting it. So this is now where R becomes interesting, and now it is now starting to challenge your mind. But you have just seen the outlook of even piping and using dplyr. It's really not hard. For those who might, all these things that you have done here, it just needs you to go and sit down over it for just 30 minutes and look at even a different challenge compared to this one. And you will see that it is something that is understandable. Is somebody having a question on what we have done? Yes? There's no question. There's this last one where you can perform even other operations using this pipe. You can go and check this also and see what this line of code means. Go and check for this. Go and check this line of code and explain it to us tomorrow in class. Something else that you're supposed to go and check is shortcut for writing the pipe operator. Go and check for that shortcut so that you don't have to be typing ISO v2 every time you want to write a pipe operator. Go and check it for yourself. Are we okay? Yes? So go and check that you can see with a click I'm just entering it. So you can go and check on that. And let's see each other tomorrow so that we even look at some other things that are more beautiful. And more beautiful because we'll just be and even whatever we have talked about here, this bit is what we wanted to talk about in these plots. So creating a scatter plot, you have seen like I used geom point, creating a box plot, you've seen geom box plot is also there, geom histogram, geom line, and geom bar. And the last one, I mentioned to you something about geom smooth and geom jitters. You'll understand what geom jitter and geom smooth does, and even geom density. If you want to talk about density in histogram, there is something bandwidth. There's bandwidth and bandwidth. You'll try to play around and see if you have it at 0.9, what happens. Let me first print this one. You can see the sizes. But now if you change geom, not geom, but bandwidth to be maybe 1.0 and try to run it again, you can see now it changes. Yeah. If you add the bandwidth to be 3, let's see. You can now see how it changes, right? So that is where now bandwidth comes in. Control +1. You can see now it has broken 0.01. You can see how now it has imeachana kama something else. Okay. Are we together? I believe we are okay. So these ones, go and also check even these codes zenye ziko hapa. They are really simple. tomorrow we'll talk about even using a legend, not even a legend or custom filling using a specific column, so that you see separate data points or data columns. You'll understand what I mean when we start working with it tomorrow. But these ones, very simple, very easy to understand. Let nobody be scared. And tomorrow let us meet at exactly 6:20. Today we started late, and because we maybe reviewed also vectors and nini for about 20 minutes, right? So tomorrow let's join in very early so that we continue